Today, we're talking about graphs and equations. In this lesson, we will solve equations by square root and the quadratic formula. We will solve by graphing, and we will discuss the characteristics of graphs. Shout out to that 3A. 3A, today on September 18th, 2024, 3A has killed it. They got down with the get down. They did beautiful work. They were most improved. Their participation was through the roof. Although a B always have together. So does all the other classes too. But I want to give a little shout out to 3H and saying, hey, you did so well today. Can you do it again like all the other classes? And shout out to all the other classes because you all have done well. And I know I fuss at you, but all in all, you guys are doing all right. Announcements. All right. There is no more optional assignments for this 9 weeks. Another big old quiz is going to take place on September 27th and the September 30th. Unless you have an excuse to turn in to me, you will not have makeup work. If your absence, hear me? Hear me well, if your absence is at least a week old and you yet turn in your excuse to me, you will not receive makeup work. If you disrupt class, it is assumed that the lecture is too easy and boring, so I must provide a challenge. The YouTube subscribe optional assignment is due on the 20th of September. After that, you will not receive any opportunities to subscribe. Optional Kahoots must be done with skill and practice to receive a grade. You must have done it at least twice. So try not to do Kahoot and score 100%. Don't do that because that's you copying answers, not really trying to learn the material. You know? So please, please, please do that Kahoot with all your effort and your might. Reminders, because you guys often forget my class. Stay ready so you don't have to get ready. This is the basic rule that many of you guys are struggling with because you guys know full well when you walk in my class, you got a quiz. You'll be faced with the quiz. So you may want to, make sure that you study the Kahoots, make sure you get all those things situated. Start no mess, and there'll be no mess. Y'all, please don't start no mess. Like, for example, having your phones out, knowing full well what's going on. I don't want to deal with no drama. Please, 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 don't put me in that situation where that drama has to happen. Don't lie to me. Own up to your mess. Work hard. Don't mess with stuff that does not belong to you. I'm reminding you guys because you guys tend to forget the rules, and then when you get reprimanded for it, or it hinders your academics, I don't want to hear it. News. I want to say starting next week, I want to start timing the Kahoot because I want you guys to understand that even if you receive a standard time or anything like that, you do not have 2, 3 whole class periods. You don't. So I need for you guys to learn how to move in a timely manner. To receive a grade for classwork, you must comply to the math principles of this course. Um, I will be pulling students at random to observe and to discuss. The restroom situation. After we did 3 examples, that's when I'm gonna start letting you guys go to the restroom. So, ain't no restroom after the 2020 rule. I'm gonna start cutting that short because all the time you guys miss out what you learn and then you fall short on it because many of you often do not want to, review stuff we've done or get notes from a friend or watch videos that I post for you. You are still responsible for the work even when you go to the restroom. Calculators, if you break them, you will buy them. Calculators will be assigned. I have new calculators that I want you guys to try. For now, you don't have calculators. I want you guys to appreciate what's given. So this is our 3 example cycle. So after I do a example, I want you to do it alone. And then I want you to work in groups. After you work in your groups, then I will go over it and address any misconceptions. During the math coursework, remember, when we do the work, it is from the dome to the paper, from the paper with a partner, from a partner with the teacher. That is how we do math in my classroom. And make sure if it's from the dome for the paper, is you doing it alone. Use your notes, thoughts, anchor charts. Write down when you're struggling. This is the part I want you guys to understand. I want you to write down questions that you have as you are working out the problem. So wherever you're lost, just take notes so I can support you on it. Show your work even when you're not sure. Writing down questions that you have as well will help you out. You're going to erase a lot, so bring your bigger pencil and don't ask the teacher during the stage of from the dome to the paper. When you are working with partners, you can work with any student you choose to. I do not care which. You can work with a number of students, so it could be one up to the whole class if you want to. Ask the question that you written down from the previous step. Discuss only the task at hand. I'm going to be pulling for specific students, but don't ask me for anything. So after we get to the partner from the teacher, that's when you ask me questions and I will address them or I will discuss misconceptions. Alright, so look, the non-phone policy. You guys, they getting strict about phones. I don't want to, be put in a situation where I got discipline. Please don't put me in that situation. So, put your phones, silence your phones, put them up, out of sight, out of mind. Polynomials and dealing with graphs. So look, you're going to start out dealing with graphs that deal with symmetry. Alright? And this perfect symmetry that you see, this is an even symmetry function because it's even around the y-axis. Alright? Well, when it crosses the x-axis, the x, well, crosses the origin and reflects around the x-axis if you want to call it that. You could call that a odd symmetric function. And I'm going to discuss those examples of even and odd. And it mainly deal with exponents of even and odd exponents. So if it's odd, that just means, I'm sorry, I was trying to go back, but I couldn't. So let's look at this picture. This is a even symmetric function because it is symmetric around the y. axis, so you want to call it even because it's symmetric around that. In class, I will be discussing this much more closely and in more detail. I will link additional videos on even and odd symmetry functions. This is an odd function because it's symmetric. Ooh, I don't know what's going on today. Nothing's working. I'm sorry. So this is odd because it is symmetric around the origin. And not only just that, the x-intercept. I mean the x-axis. So that's how we could determine even and odd symmetric. This is not symmetric. So no. What is going on today? For the life of me, this is not working. This is not symmetry. Has no symmetry. So here, this is what you have to write down. And you have to know. Polynomial graphs are smooth and continuous, meaning that the graph does not have any gaps or holes. They keep going. Remember, a polynomial consists of non-negative integer exponents. Rational functions, radical functions, and absolute value functions are not polynomial graphs, and those are the things that you're going to learn before you take your test. Given a function of axn plus bxn minus 1 plus cx plus dot 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 n, where the biggest exponent usually in the front is called the polynomial function of degree e. The coefficient attached to the highest exponent is called the leading coefficient. So let me explain all this because I know this is a lot. So remember coefficients before we get on to the leading coefficient test. So remember when we was dealing with factoring our quadratics and we was dealing with our trinomials. This is taking so long. Anyway, so the leading coefficient test. And we know coefficient is the number in front of the variable. So when you're dealing with the end behavior, you must pay attention if your coefficient is positive and negative and the biggest exponent. Like for example, you know this trinomial. You know this so well. X squared plus 5x plus 6. Alright? So, let's move into it. The leading coefficient tells you when the graph falls and rises. Alright? And you're going to have graphs that looks like this. Now, the only reason why I brought up this trinomial because I was just trying to show you about leading coefficients and stuff like that. And so in class, we're going to, discuss this in detail. So let's look at this graph here, though. So it falls, well, it rises, then falls, but ultimately it rises at the end. So basically, you're looking for when the graph starts and when it ends. So you see that it rises in the beginning, and when at the end it rises too. So that's going to let you know if it's positive. And now let's get into some details. So when you are dealing with a leading coefficient that's a positive number, that just means that if it's an odd degree function, that just means that it's going to increase from the negative side, and it's going to keep increasing from the negative side. All right, but if it's negative, and if it's an odd symmetric function of odd degree, that just means that it's going to fall and it's going to keep falling. So when it's an even degree, if it's positive, that means it's going to fall, then rise. And then if it's negative, it's going to rise, then fall. And I'm going to give you some more examples which will help you a little bit. So let's look at these endpoints. You see how this falls, and then it rises? That's how we know that we are dealing with an even function. But then you look here, it rises, but then falls. So that means that it's a negative coefficient, even degree function. So this, we know for a fact because it's symmetric around the origin, we know that this is going to be an odd degree function or odd symmetry function. However, you worry about the end, meaning that it rises and rises, or if it's negative, it's just going to fall and just keep falling. So that's when you're dealing with the odd function. All right, max and minimum. The highest point on the graph is called the absolute global maximum, and the lowest point on the graph is called absolute global minimum. Any hills are called local and relative maximum, and any dips are called local and relative minimum. So when you see this, the lowest point on the graph, the lowest, is going to be the absolute minimum. So therefore it's negative infinity because it's from some very small number. But the largest thing is called the absolute maximum. The local minimum is like a small dip. Well, that's a local maximum. Well, you see any dips, those are called local minimum. Alright, special note. The plural of maximum is maxima. The plural form minimum is minima. Maximum and minimum are correctly called the extrema. We will always use x values for intervals. For specific purposes, x and y are commonly known as x and y. Right? And make sure you guys apply your previous knowledge about the coordinate system. So here, when you're dealing with polynomials, you gotta describe increase, decrease, and you gotta talk about turning points. So when we get graphs, we're gonna look for, does it decrease, increase, turning points, and don't forget about multiplicities. So again, multiplicities, as we have noticed, are repeated factors, not zeros, but repeated factors. Because usually if they repeat, that means it's just going to be one solution regardless. So if it's one solution, it's going to cut through the x-intercept. Well, one factor, sorry. But if it's two factors, repeating factors, that means it's just going to touch the x-axis and bounces. If it's three, which is the largest number you have to worry about graphically, that's when it just, lies flat. So you see how it just plateaus for a little bit? It plateaus before it rises or falls. And that's when when you got a multiplicity of 3. Remember, zeros are the x-intercept, which is the visual of our functions. So multiplicities deal with zeros, and x-intercept means the same thing as zero. So when it either touches the x-axis or when it crosses, which is the x-intercept. All right, so here I left you an example to see what I'm talking about. So this is not a perfect symmetry, as you can see. So we cannot say that it's a symmetrical function because it has to be symmetric. However, we do know that since the graph falls, but then at the end it rises, we know that this is an even degree function. The absolute maximum is the highest point of the graph, which is infinity. And we know the lowest point of this is negative 1.54. But we have some local maximum and minimums to deal with. So maximums are your hills and your minimums are your dip. Because they are not the lowest or the highest point, you still got to discuss them. So 2, 0 is a local maximum. And then a local minimum is not negative 4, it's for negative 1. All right. So next, deals with multiplicities. Okay? So we know multiplicities are just repeated factors, but we know them through the graphs for when they crosses. Like for example, you have a multiplicity of x plus 3, but we know that that 0 is negative 3. And we get negative 3 because we solve these multiplicities and we get negative 3. And so that's a 0 right there. And the only thing we gotta do is just inverse the negative 3, put positive 3, put an x in front of it. And since it cuts through the x-intercept, it has a multiplicity of 1. Now, we notice that we have a 0 of positive 2, right? If we go backwards and rewrite it as x to be negative 2, and we see that there's a multiplicity of 2 because it touches 2, doesn't cross through it, but it bounces off from it. So, if you need to see how we get from the multiplicity of x minus 2 and the 0 to be 2, we just solve for x. So x minus 2 equals 0. You add 2 to both sides, get x equals 2. And when you do that, that is your multiplicity. And that multiplicity is your 0 right there. All right? Then let's look at the multiplicity of -5. So -5, we notice that it crosses the x-axis just one time. So we know that if we solve for x, we get positive 5, which is a 0. But because it cuts through the axis, that means it's going to be x minus 5. The factor is going to be x minus 5 with a multiplicity of 1. So before we continue, let me give you a little bit more detail. All right? So we can get through this. So we notice that the zeros are -3, 2, and 5, right? So when you're dealing with multiplicities and when you're looking at the graph, you have to look at how, the graph is going through, is acting. So if it cuts through, meaning the x-intercept, that means you only have one multiplicity. So that means you're going to have to take that 0 or your answer and you're going to rewrite it in the factor form of wherever it was. So if it was -3 is to 0, that means you're going to rewrite it as plus. You feel me? And if it's 2, and you see how it bounces off 2, that means instead of writing it as 2, because 2 is your 0, the factor form of your solution that is 2, you write it as x minus 2. And because it bounces right here, that means you're going to have a factor of that. Let's look at 5. You see how 5 cut through the graph once? Well, that's the answer, but if we go backwards, it's going to be x minus 5, and because it cuts through, it's going to be your x-intercept on once, and you rewrite it like that. All right. I want you to try this on your own and just see what you can get with. Try it on your own. And of course, I know this is a little hard, so I'm going to help you along the way, okay? So pause the video and try it. All right, let's do it. So let's go through all of this. Now, let's start out with the zeros. So we know that the zeros is -3, -1, and -2. So we're going to go from the zeros to the multiplicities. We're going to go backwards. And then I may go forward just so you can see what I'm getting at. So let's look at x, the intercept of x equals -3. So So that's the answer. So that means if we go to the multiplicity, the factor form of that answer, instead of being x equals 3, it's going to be x plus 3. And the reason why that happens, because that's the factor. But if you was to solve that factor of x plus 3, you set the 0, subtract 3 from both sides, and you get x equals -3. That's what you get. Good? All right. So let's look at -1 as the second 0. You see how it just stays flat at -1? It doesn't cut through or bounces at 1. That means you're going to have a multiplicity of 3. But because it's at -1, we're going to go backwards. So 0 is -1, so its factor form of that 0 is going to be x plus 1. And because you see that it lays flat, it's going to have a multiplicity of 3. I know why I put -1. It's plus 1. And let me explain why to you again. Because again, we went from -1 x equals -1. We went back to the factor from x plus 1. But if you take the x plus 1 and you set the 0, because that's a 0 um, pro product property, setting your factors to 0, subtract 1 to both sides, you get x equals -1. So that's how we go from zeros to the multiplicities. And that's why I got x plus 1 to the power of 3. Alright, so let's do the last one. So you get positive 2 here. That's a 0. Well, by now you begin to see the pattern. So if it's positive 2 here, that means the factor form of that 0 is going to be x minus 2. And because it bounces at 2, that means you're going to put it that square because it has a multiplicity of 2. Alright? That was a lot, but we covered it. So, again, it's not perfectly symmetric, so you can't talk about it. It's an even degree function because, look, it falls, but then rises at the ends of the function. And I'm sorry that I went too fast, but you should replay the video, address everything else. If you have any questions, just talk to me so we can address it. Alright, remember the quadratic formula. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. Alright, so just remember, when you're doing the quadratic formula, if the square root is positive, you're going to have two real solutions. If the square root is 0, you're going to have one solution. If it's a negative number in the square root, it's going to be two imaginary solutions. And remember, a negative number in the square root becomes imaginary. So pause this video and do the quadratic formula. And if you forget the quadratic formula for this problem, just remember x equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. Pause the video and try it. Alright, so if you have did the problem using the quadratic formula, cool. If you didn't, please try it. So of course use the formula. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. So you put everything in place. You did that. You got negative 144 in the square root, which you know can never happen. And you get 12i. And you get plus or minus. Either you're going to have plus 2i or minus 2i as your final answer. If you're struggling with this, all you're doing is just putting the numbers in the formula. Alright, I want you to try another one of these. So pause the video and try this one. Using the quadratic formula. Alright, by now you have did this problem using the quadratic formula. And we're ready to review. Did you realize that A is 1 because every x has a coefficient of 1 by itself if there's no number there? B is 5, C is 1. So you use the formula, you put in the correct place. You get square root of 21. Alright. I went a little too fast, but you could go take care of that because we've been working quadratic formulas. Alright, try these problems. Try this one. Pause the video and see what's up. But this is the one that I want you to look at decimals for. So put this in decimals, and you're looking for your x-axis, and when the graph touches or crosses your x-axis. Alright, pause the video and let's just see. Welcome back. Alright, I know you guys are good with the factoring. I also know that you guys know how to use your zero product property, which is set every factor to 0 and get your answers. Those are the answers that we did algebraically, but graphically, because remember we're looking for when it touches or crosses the x-axis, and we get the same answer. And it cuts through, so that means each of these factors have a multiplicity of 1. Alright, I'm going to leave you with this one. I want you to try this one. And I'm going to leave you with that.